Hello, welcome to Lyons Township High School AP Physics. Today we have the classic boat in the river velocity problem. So let me describe the diagram to you. You may want to pause the video briefly and copy this diagram down. So I'll pause for a second. All right. So what's the video here, or what's the diagram here? Well, we have our river. This is one shore, and this is the other, and the river is flowing to the east at 6 meters per second. And the notation here is the velocity of the water with respect to the ground. We have the boat, who for now is going to point due south. His compass will say due south, the pilot of the boat. And that velocity of the boat with respect to the water is 8 meters per second. The stream is 200 meters wide, okay, and he's starting from the shore at time equals 0. So here are some things that we're going to figure out. We're going to figure out what's the velocity of the boat with respect to the ground. In other words, if you're standing here on the dock, watching the boat go away from you, which way is the boat going? Okay, he's not going to go due south because the river is sweeping him to the east. We're also going to find the time it takes for him to get to the other shore. Okay, we're going to find how far downstream he gets swept. So he's getting swept to the east. So we'll call that D. In other words, you know, where does he land? He's going to land over here somewhere. How far is that from the straight across spot? Okay. Finally, we're going to figure out which way would he have to point and exactly what angle would he have to point to correct. Meaning, what angle would he have to point so that he actually goes straight down and hits this spot here. Okay, that'll be the final thing we'll find. All right, so first up, what's the velocity of the boat with respect to the ground? Well, the velocity of the boat with respect to the ground is simply the velocity of the boat with respect to the water plus the velocity of the water with respect to the ground. Now, you don't have to, oh, this is G. You don't have to do this, but a note, oh, wait, and I messed that up. This is the velocity of the boat with respect to the water plus the velocity of the water with respect to the ground. Now, again, a note, if you're doing this right, these will cancel out and you're getting your answer. Now, you don't have to do that with notation, but it's kind of cool. All right, so these are vectors. You can't just add 6 plus 8, okay? You have to do the vector triangle. So I'll do that down here. So we'll do the 8 first, and then we'll do the 6. If you were to Pythag those, you get 10. Okay, it's a 3, 4, 5 triangle. And if you find this angle here, that's the angle he's starting at, okay? That angle would be inverse tangent. There's 3 ways to find that, but I'll use tangent. Opposite over adjacent leg, which is 6 over 8. And if you get that angle, you're going to get about 36.9 degrees, okay? So our answer to the problem is the velocity of the boat with respect to the ground is 10 meters per second at 36.9 degrees. And he was trying to point due south, but he's getting swept 36.9 degrees east of it. So it's 36.9 degrees east of south. Okay. Now there are other ways to express that angle. For instance, you could do the complement here, which would be, let's see, 63.1 degrees, and you could say 63.1 south of east, or you could say 63.1 degrees from the shore would also be another way to express that angle. Those all mean the same thing. So just be, as long as you mark the angle and you're clear on your description, that should be fine. Now, how long does it take to get across? Okay. Well, we're going to use, here's the key. A common mistake that people make is to say, okay, my velocity is 10, I'll take 200 divided by 10, and I'll get my 20 seconds, and problem's over with. Well, that is unfortunately incorrect, okay? You want to know how long it takes for him to go 200 meters south, okay? What velocity do we need? Well, we need the southward velocity, okay? He's moving 8 meters per second south. How long will, it doesn't matter what's going left and right, okay? All that matters is what's going on south. He moves 200 meters south at a pace of 8 meters per second south. That's going to give us our time. The velocity of the river is actually irrelevant to the time it takes to cross. This thing could be 1,000, okay, and he's still going to take the same amount of time to cross, okay? The only difference will be when he crosses, he would end up way over here somewhere, okay, but the time won't change, okay? So what we're basically doing is we're saying delta y, and I'm calling it y because it's a vertical distance, not a horizontal, equals vyt. We know delta y is 200, vy is 8, not 10, it's 8, and then time. And you get the time to cross to the other shore is 25 seconds, okay? So it's going to take him 25 seconds to cross. And by the way, that is the absolute fastest time that he can cross in. So if he were to point his boat west or east at all, then he has less than 8 meters per second of a velocity due south, and it'll take him longer to hit the other shore, okay? Now, how far downstream does he end up? Where does he end up over here? Well, now you're going to use delta x equals vx times time. In other words, the x and the y velocities are independent of each other. Delta x, which is our distance, is vx. Well, he's moving to the right at 6 meters per second, times time, which is 25, and you're going to get 150 meters, okay? So you could draw a separate triangle here. You could draw a displacement triangle. This distance is 200. This distance is 150. You could find the distance relative to the ground or to you standing on the dock. How far is the boat away from you when it lands? Well, that's going to be, the Pythag goes, you're going to get 250 meters away. That angle will be exactly the same as this angle, which is 36.9 degrees. So, now by the way, note, this is a velocity triangle. This is a displacement triangle. I'm not putting any velocities in here, and I'm not putting any displacements in there. That would completely mess up your vector addition, okay? Finally, which way does he have to point to get straight across? So now he wants to land here, okay? So I hope you'll notice that he'll have to angle the boat a little bit west, okay? So I'm going to draw that in the next board here. He's going to have to point his boat west. Now, his velocity with respect to the water is still 8. He can't change that. It's a boat in water. The velocity of the water is still 6. What we want is, when we add this and this, we want the result to be straight across. Now, one common error that people make is they say, okay, if this angle is 36.9, well, maybe you have to point 36.9 that way to get the right answer, to figure out which way he's got to point his boat to get straight across. Well, you may notice that that's not right, because the hypotenuse is not, it used to be 10, now it's 8. It's a different kind of problem, okay? We have, to find this angle, we have the hypotenuse and the opposite leg. We're going to use sine. So the angle is inverse sine of 6 over 8. And if you do that, I'll save you the work, you get about 48.6 degrees, and he is pointed west of south, okay? So he's here straight south. He has to direct himself 48.6 degrees west of that, which is significantly bigger than 36.9 degrees, okay? Finally, how long will it take him to cross now? Well, we need the across southward velocity. I'm going to use Pythagorean's theorem for that. The hypotenuse squared equals the one leg squared plus, I'll call that Vy squared. Okay, so Vy equals root 28, which is 5.29 in my calculator. So notice that's a lot less than 8. He's crossing much more slowly than he did before. Okay, to find the time to cross, we're going to use delta y equals Vyt. Delta y is still 200 across the stream, but now we got 5.29 times time. Time, if you do the calculation, you get just under 38 seconds, which is a lot longer than the 25 it took before, okay? So the benefit is he does now get straight across. The downfall is it takes him significantly longer to cross, okay? So we hope that was helpful, and thank you very much.